Okay, so an important thing to understand about this column on our course plan is that this is where you'll find things like videos that will help you in the assignments that you're doing on ALEKS. And so it would be a good idea most of the time to watch these videos before you do the work in ALEKS, because this will serve as a lecture for you. And when you get stuck on ALEKS or you need help, this set of videos will be a good place for you to come to try to get help, in addition to being able to reach out to me to get help as well. So with that, we're going to start with scientific notation today. It is the first lesson that you're going to have in ALEKS, and it is a little bit different than the subsequent lessons that you will have, because this is an actual ALEKS assignment, and what follows after that will be what we work in what we call modules. And so there'll be a slight difference after we complete this first assignment to what comes next, just in terms of the way that you interact with ALEKS when doing it. But you'll always have a written component like this and videos of me helping you understand the topic, and then the work that you're going to do on ALEKS as well. So with that, scientific notation is something that we'll be tackling today, and we'll be talking about it in terms of just another way to write a number. And so there are, for the purposes of this conversation right now, two ways to write a number. One of them is what we call standard form, which is like the number 700,000 there. That is written in standard form or standard notation, whichever you would like to call that. And then there is another way of writing that same number in a form called scientific notation, which is an example of scientific notation is what we see in problem number 2. And so we need to be able to move back and forth between these two forms fairly fluently. And so the simple way to describe this is if the number, we're going to be dealing with exponents as we do this. And if the number is bigger than 1, the exponent that we have is going to be positive. If the number that we're dealing with is smaller than 1, like this one here, the exponent in that case would be negative. And so I'll just put a note here at the top for myself really quick. Bigger than 1. Or larger than 1 is a positive exponent. Smaller than 1 if the number is smaller than 1, it's going to be a negative exponent. And that's really all we need to know in terms of scientific notation, other than one other thing, which is where to put the decimal and how to write this form. And so starting off, for 700,000, our decimal is right there. And the goal of scientific notation is to only have one number in front of the decimal, and that number has to be a number that is not 0. And so to get there, I want the 7 in front of the decimal. I need to count how many spaces I need to move the decimal to make that happen. And so count with me: 1, 2, 3, 4, 5. I had to move the decimal 5 places to get it to where it would only have one number in front of it that is not 0. So that number 5 is going to be important in a moment. We're going to say that this is now 7. And to write this in scientific notation, we're going to say it's 7 times 10. And we had to move it 5 places. So 7 times 10 to the power of 5. This number here is equivalent to, or is equal to, 700,000. It is not different. We did not change it. We are just writing it in a different way. And again, that number 700,000 is larger than 1. So we do have a exponent that is positive, in this case being positive 5. On to number 2. We have 8 times 10 to the power of 3. Now again, this exponent is positive, and so it tells us that our final answer is going to be larger than 1. And so right now we have an 8 as our number with a decimal behind it. And that 3 says to move the decimal 3 spots. So 1, 2, 3, and I'm going to the right instead of the left because I need to make this number larger than 1, not smaller than 1. And so doing that produces the number 8,000. And so as we discussed with number 1, 8 times 10 to the power of 3, what we started with, is exactly the same as 8,000. We're not changing anything. They mean the same thing. We're just writing the same number in 2 different ways. All right. 5.52 is our next one. So we've got 5.52. times 10 to the 5th. Now that 5 right there is positive, and so it says we're going to end up with a number larger than 1, and it's telling me to move it 5 spots. So 1, 2, 3, 4, 5. We fill in the empty blank spots with zeros, and we get 552,000. And again, this 552,000 is the exact same number that we started with, which was 5.52 times 10 to the 5th, just written differently. And on to number 4. We're asked to write this one in scientific notation, so we can look and see that our decimal is right there. And we need to move, to have only one number in front of it, we need to move to the left 1, 2, 3 spots, which leaves me with 7.553 times 10, and we moved 3 spots, and it is a positive 3 because our original number was larger than 1. Alrighty. Number 5. Now we have negative exponents, which means that we are going to end up with a number that is smaller than 1. And so the movement of the decimal this time is going to be to the left, not to the right. And so we have a 9 with a decimal behind it, and that decimal needs to move to the left 5 spots. So 1, 2, 3, 4, 5. The decimal is going to end up right there. We fill the empty spots with zeros. So me personally, I like to put a 0 in front of the decimal. So 0 point, and then everything that I have over there. So 4 zeros and then a 9. And so this is equivalent to 9 times 10 to the negative 5. Exact same number, just written differently. Next, we have a 3 to the power of negative 2, so a number less than 1 because the exponent is negative, so we need to move the decimal to the left. 2 spots. Fill empty spots with 0. And I like to put a 0 in front, so we end up with 0.03 as our final answer for this one. Number 7, we want one number that is not 0 in front of the decimal. And so to do that, we need to move the decimal 1, 2, 3, 4 spots, which makes us at a place where we have 7.35, and we moved 4 total spots, so times 10 to the 4th. But I need to remember to make sure that I say that that 4 is negative, because this number is less than 1. Very careful, need to be very careful with the positive or negative exponents that we put on these things. And I should say, feel free to pause at any point here, and I'll leave this here for a moment so you can pause if you'd like to check your work against any of these answers or watch any part of it again. Number 8, very similar to the last one, we have 3.254, and I'm going to move that a little bit. And that's to the power of negative 2, so a movement of 2 decimal places to the left. So 1, 2, and we get 0 in that spot, and that gives us 0.03254. On to number 9 and 10. For number 9, we have the diameter of Neptune, equator is that big. Write the number in standard notation. So 4.95 times 10 to the 4th. And so this number is much larger than 1, so we need to move the decimal to the right. The exponent is positive, so 1, 2, 3, 4. Fill in the empty spots with zeros, and that gives us 49,500 kilometers. On to part B. We have an astronomer's infrared telescope is able to detect radiation with a wavelength of that size in meters. Write this number in scientific notation. So we're starting with 0. I'm actually just going to count from up there. So we have, to only have one number in front of the decimal, we would need to move 1, 2, 3, 4, 5 spots. And so we would have 3.81 times 10 to the 5. And we can think, should that 5 be positive or negative? That number is less than 1, so that 5 should be negative. So 3.81 times 10 to the negative 5 meters is what we would have for part B. On to number 10. The surface area of South America is approximately 6,890,000 square miles. Write this number in scientific notation. So we've got our decimal place right here. We would need to move that decimal 1, 2, 3, 4, 5, 6 places to get it to only have one number that is not 0 in front of the decimal. So we're going to have 6.89 times 10 to the 6th square miles. And we need to pay attention that exponent should be positive because the number we are dealing with is larger than 1. Part B. The signal from a certain satellite takes approximately 1.3 times 10 to the power of negative 2 seconds to reach Earth. Write this number in standard notation. And so we're going to have the number 1.3, and it's 10 to the power of negative 2. So this number is going to be less than 1, so our decimal needs to go to the left 2 spots. We fill in the empty spot with a 0, and that's going to give us 0.013 seconds. All right, that's going to be it for this written homework assignment. I hope that this was helpful, and I hope you have an awesome day.